Greetings, everybody. Happy May Day. It's lovely to be together and to celebrate being together in our troubled world. I'm Valerie Fletcher. I'm the Executive Director of the Institute for Human-Centered Design, and we are very pleased to bring another session forward today about a topic we think is critically important, and that is the role of neuroscience in relation to architecture. I am so pleased that we have a colleague and friend, newly made in the last year, but very important in our work already, and that is Ali Heshmati, who comes to us as somebody intrinsically committed to multidisciplinary, multi-design work. He is an architect, he is an artist, he is pursuing his doctorate in neuroscience. He touches a little bit of everything. And he is coming to us today from Bergen, Norway. And I'm pleased to say that we've got a wonderful international crowd, folks from Brazil, from the UK, from Dubai, Spain, our friends in Canada. Those of us in the US want to make very clear our friends in Canada are very valuable to us. And I wanted to let everybody know that this will be open caption throughout. And we will also post it when it is completed, and we have edited the captions on our website within 2 weeks. So that is something you get a second bite at the apple very quickly. I also wanted to announce, and I think it's been announced on the chat, we have permission now to offer AIA credits for those of you who are interested, and the method for doing that is explained in the chat. So welcome to those architects who seek those credits. And without further ado, I am going to welcome Ali to take over.
Hello, everyone. Let me try to start sharing. Let's go share. And as soon as I'm there, share. And we go to slideshow from start. Well, the title of the presentation today is Circadian Neuroscience and Built Environment. I have to sort of explain that as big as the word architecture is these days, when you look it up, you would probably get more than architects. Everybody's an architect. The word neuroscience itself is a huge word also, and the discipline is varied very much. What people say neuroscience, when people say neuroscience, it's just a huge sort of discipline of different interests. So circadian neuroscience, generally looking at chronobiology and neurobiology of systems, system that we call circadian system. And I will talk about that a little bit here. As you heard, my name is Ali Heshmati, and I'm an architect and public artist, and now trying to sort of learn a little bit about circadian neuroscience and become one. I want to start with this slide because I do believe that at the end of this webinar, you should have an idea about what it is that makes you more than just designers and architects of the built environment. You are essentially, or you should be, physicians and doctors, because people spend a lot more time in the built environment itself than going to doctors. We'll talk about this a little as we go through. So let me see if I can manage this. All right. I've been practicing architecture and public art for about 30 years, and out of that, the last 10 years, I have been sort of focused on how the built environment really shapes us. You know, the first 20 years I've been focused on making buildings that help users and communities to live, play, learn, heal, and be active in a good way. Shaping functional environments that are technologically and materially sound, functional, and aesthetically pleasing. Very much back to sort of origins of architecture, if you will. I see architecture as and urban design as a stage for life and cultural interaction, a sort of world theater, if you will. But architecture there is not just a stage, but active part of this theater. As I'm talking, you're looking at some of my work, which is here and there, different places. I have to say that when I look at my work, I see that I've been preoccupied with light for the duration, whether it has been architectural work or installations here and there, large scale light installations. I have always been interested in light and light's role in architecture. But now I really want to bridge the sort of gap between the latest neuroscientific knowledge and evidence with the human environment, with what we call architecture and urban design, if you will. Interior design included. When I say design and architecture now, just imagine I'm talking about everything that is related to built environment. I'm not just talking about architects and architecture. So don't want to sound a little exclusive. Here it is. Let's get into it and why I'm focusing on light generally. In this webinar, I want you to sort of understand circadian rhythms and the role of light in the environmental sort of entrainment or synchronization of it. I want you to understand daylight and lighting's role in the built environment, as well as this circadian system that we were talking about. That's the connection. And we will be addressing the current regulations and standards in daylight and lighting. Plus, we discuss a few optimizing design strategies to promote health and well-being throughout the design. Beyond vision, light plays a crucial role in the health and well-being of all of us. Light is perhaps the most tangible but ethereal material of life and architecture, both. Light is a life-sustaining source, as you know, with great influence on our sleep consolidation, mental and physiological health, mental and physiological performance, happiness, and well-being all alike. Light is life, if you will. Over 3.8 billion years, life's rhythms on Earth have evolved in direct response to the temporal availability of daylight. We call these rhythms, these natural rhythms, circadian rhythms, which govern our physiology as well as our behavior. Billions of clocks contained in every cell of our bodies control these rhythms. And they must be synchronized, otherwise it would be chaos, right? They must be synchronized or entrained, we say entrained, to run an orchestrated, to have an orchestrated performance, if you will. This is also a survival mechanism for us. If we didn't wake up in anticipation of daylight and light and day, we would be definitely lunch for the predator coming around. So most of our predators are diurnal animals. And these rhythms allow us to survive, actually. So our daily physiological and behavioral rhythms must synchronize, as I said, with the 24-hour daylight, light and dark solar cycle, right? Sorry about that. Located in the hypothalamus of the brain, our master clock. There is a master clock that does this in our interior environment, if you will, or it's a endogenous pacemaker for the system. It tunes the system automatically on a sort of a circa 24-hour system. Usually, for most of us, this is running over 24 hours. That means would be 24 hours and let's say 15 minutes or 10 minutes, or maybe even 25 hours in some extreme measures. And then on the other hand, there are some people that run a little shorter than 24 hours, like 23 some, 23, 30 or so it's not an exact 24 hours, and it is the daylight that is the most significant environmental pacemaker or trigger for this system. Send a light signal through the eye, to the brain, to this master clock to set us up for the day activity or lack of light for the night activity. So as I said, the light-dark cycle is extremely important to this system, to fine-tuning this system. Daylight is the most significant environmental pacemaker, but there are other sort of cues or pacemakers that we don't need to talk about. They are not as effective or as important. Light's intensity, spectral power, or color, as you call it, timing, duration, and the spatial distribution have a direct impact on these rhythms. Their intensity, their sort of amplitude, which we'll talk about, have direct sort of relation to all of these aspects of light that I talked about. Disruption of the circadian rhythms now, I want you to know, have also adverse consequences on our health and well-being. So let's just look at the way light sort of enters the eye from the environment and goes through and gets projected on the retina, and then from the retina, certain signals would travel to this through the hypothalamic tract to the suprachiasmatic nucleus, which was, it's a really two bundles of about 50,000 neurons that receive the light signal, and from there going through certain other pathways to get to pineal gland to express melatonin, right? So blue light is the most important sort of part of the light that impacts these newly found neurons called the intrinsically photosensitive retinal ganglion cells directly. So light in general has effect, but the major sensitivity of the neurons that were found, just about these type of neurons that were found in year 2000 about, are the blue light, and we will talk about that in a second. So our brain doesn't distinguish between daylight versus electric light, right? Light is light for the brain, except the parameters that I talked about, the intensity, the spectral power, and then duration and timing, and spatial distribution. So this is exactly why we can use electric light to simulate some of the effects of light, for example. Let's go through, and so you saw all of those neurons. Imagine your eyes are really two parts of your brain sitting outside your skull, and dealing with light detection. And then light goes through this system of phototransduction, doing certain things. As I said, there are, we used to know about 4 sets of neurons, rods and cones. And then the 5th type, this intrinsically photosensitive ganglion cells, were discovered around year 2000. They are doing the melanopic light detection, or the light detection that relates to all of these good impacts, right? Circadian rhythms, sleep, alertness, cognition, mood regulation, hormonal release, and metabolism. So these light detection, these neurons for this light detection and phototransduction are different sets, and we will look at them in a second. Here, I want you to see at the look at the peak sensitivity of these different neurons. As you can see, rods, for example, have a certain sensitivities, and cones, as you know, are the color vision sort of neurons, and then we have the IPRGCs, or the ganglion cells that we were talking about. This is just a selected number of all ganglion cells that we have. Okay, so that said, it is important that we know that we pay attention to non-image forming light detection and its system in what we do as well. We will talk about that in a second. Let's talk about, let's go. Yeah, here you can see the effects of light on the type of neurons that we were talking about. These are the non-visual effects of light, we call them, because the visual part goes through the rods and cones and goes to another center in the brain and does its thing, that's what you see. And they're very sensitive to light, and those neurons, and they are very fast in phototransduction, which is very different than this other system. We will get there in a second. But for you just to see what are the impacts or what are the processes that are included in non-visual impacts of light. There is, of course, another part to the impact of light on health, which are not included in our sort of webinar today, but you can just take a look at it fast here and see that sunlight or daylight has numerous amount of impact on our health in many different ways, right? So then we're gonna be now looking at the disruption. What are the impacts of disruption of this circadian system? So you can see here that we have the acute emotional responses that happen just as light is there or not. So when is light, shining, let's say during early hours of the day, most people are very happy. Most people are less anxious and less irritable. and so on and so forth. And then as it goes, you can see it in acute cognitive responses as well. Lack of light and disruption can cause all of these and more, perhaps. Then there are chronic health impacts. These are some of the most dangerous sort of life-threatening impacts that lack of light or a disruption of circadian system and sleep can do to us. So I'm going to scare you a little bit here, but this is matter of science, right? So I want to also right here share with you a study that was done in 2016 on what is called fluoxetine. Fluoxetine, as you know, is sort of generic name for the drug, the active drug in Prozac. Prozac is used for depression, antidepressive medicine, as and it works in a way that if someone is clinically depressed, which is in this scale, you have to be up somewhere to be clinically depressed. You're not clinically depressed here. Being sad is different than being depressed, right? And then, so as this scale falls, that means you're less depressed. They had 120 people, a randomized blind study. They divided them in 30, 30, 30. Then a bunch of them received placebo. 30 of them received placebo. And you can see that in 8 weeks, placebo had a sort of a good effect, about six scale down on depression scale, which is really amazing for just, sugar pill or whatever they gave them. Then we are going to be looking at fluoxetine itself. This is the drug. And as you can see, all the way to even 4th week, the drug is working pretty much like the placebo. But it is only about 6 to 8 week that starts making an okay difference, about 2 scales, right? But then we're going to be looking at light. 32 people received light alone. You're talking about light therapy. That's about 10,000 lux of light, about 2 hours in the morning they received. And this is the effect of it. It is amazing for me to just look at this and see how light has performed in 8 weeks. How much better than fluoxetine. Fluoxetine, of course, has side effects. We're not here to talk about fluoxetine's side effects, but we are here to talk about light. And as you can see, more than 12, almost 14 on the scale, lowering depression. This is an amazing non-pharmaceutical, drug essentially, right? But then, as all good scientists have to do, they do a combination of fluoxetine and daylight or light, and this is what they got. They got even better result. But you can see between fluoxetine and light, there's a bigger difference than between light and combination. That also tells me a lot, right? Okay, I showed you this because I just want you to know that light has a measurable impact on different aspects of our health. It is easily measured, and it is being measured all the time now, and throughout the scientific sort of community. Now, I'm going to play a little game with you, and I want you to use the chat and interact with me a little bit. I don't see the chat, but I would hear someone talking about it. I'm going to show you this slide, and I'm going to define for you lux, which is a measure of light we use. One candle produces 1 lux of light at 1 meter, or as you would probably think about it as at about 3 feet on a surface that is 1 meter by 1 meter. Okay, so that's the definition of lux. And I know that most of you have gone out and walked in the moonlight. I want you to guess how much light would moonlight put out. Just put some numbers out in terms of lux. Remember, 1 lux is 1 candle at 1 meter away. That's the amount of light.
We've got 5, we've got 20.
Okay.
1/4.
Okay.
We've got 1/4. We've got 10.
Okay.
We've got 1 in
Yep.
10 lux. We've got 0.
Okay, that's all right. This is good. This is good. I'm so glad that you guys are so close. Actually, a third of 1 lux. I mean, 0.3, less than a third of 1 lux, which is amazing. I mean, in that light condition, you can see your shadow for sure. You don't see colors, of course, but you see your shadows. I'm going to show you a couple of these and then ask you for another one. So, for example, museum displays, you can sort of see about 50 offices and homes differ from, somewhere between 50 to 500 lux of light. I want to ask you again, early sun, what do you think that, how much light would that put out? For sure, it's more than 500. So remember that's a clue. Early sun, anybody?
70,000? 10,000?
Whoa, okay, cool.
100,000.
So early sun outdoor would have around 3,000 lux of light, which is, interestingly, it's the amount that you would get by a very large window, in very close to that window by a large window. So about 3,000 lux of light we're talking about. Outdoor shade, on the other hand, in spring days, for example, we're talking about 10,000 lux of light. And then when we talk about full sun puts out 100,000 lux of light on Earth when it is shining well, right? So I want to just share with you some info on these rods and cones. Talk a little bit about them and work them through. So rods are neurons in the retina that relate to motion and low light vision. And they can sort of do the phototransduction and the resulting vision in matter of milliseconds. That means if you turn your head, you can see something right away. This is because they are working very fast. They are sending chemical and electric signals to the vision center in matter of really milliseconds, right? And then you have the cones, which are less sensitive to light. They see like around 10 lux up, you can start seeing color. So they do their work mainly from there on. And they go all the way to, highest light vision. Of course, you don't look at sun, but you can, not looking at the sun, you can see very bright lights at very harsh conditions. But sunlight is also very diffuse. The skylight is very diffused. It's not as glaring and sort of harsh as electric light, right? And if you notice, I'm not going to be using the word artificial light because there is nothing artificial about the light that comes from the artificial source. The light is, as natural as any light. It's electromagnetic wave, and nothing about it is artificial. So these other sensors or photosensors that we are talking about were discovered about the year 2000, and they're called intrinsically photosensitive retinal ganglion cells, and they are really sensitive to higher amount of light, and they take longer, minutes to hours, to process and do the photo transduction and get the resulting sort of circuitry filled with it. So as I said, these are the ones that are responsible for photo entrainment of the circadian rhythms. They're responsible for your mood. They're responsible for your focus, and so on, which we looked at. Okay. Now, why is this important? Well, it is important because we are spending more and more time in interior environments. This is a study from 2001. There has been some studies after that, but this is probably the most cited study, which talks about Americans, activity of Americans throughout the day, and talks about, less than 7.6% of our times would be spent outdoors. So of course, this is very, by today's standards, this is very, very optimistic. I'm going to ask you another question, and that is, again, you respond to it on the chat. Yesterday was Wednesday. I want to know if any one of you spent more than an hour during the daylight outdoors. If you were working, of course. If you're not working, it doesn't count. Anybody spend more than an hour outdoors?
Somebody spent 6+ hours, and she works for us.
Oh, that's good. She's been working outdoors, huh?
She was in a botanical garden yesterday. Yes.
See, that's amazing. But botanical garden was it's amazing. So that kind of work is really more fun than work, right?
Yes.
But if we really get to the sort of bottom of it, most people are spending less than an hour during the daylight hours outdoors.
We have
And
mostly people, yes, most people said none or minutes. Yes.
Yeah. This is
one person doing construction had many hours outside.
Oh, this is here. That's why I'm envious of construction workers and people working in, botanic gardens. This is amazing because there are certain number of us that still are doing this. If you go back about 100 years ago, really majority of people will spend majority of their daylight hours outdoors. Of course, we even then had bureaucrats and others that had to be indoors and spend hours indoors, but most people were outdoors. So now, if you live to be 100 years old, you have spent less than 7 of that outdoors. That is just mind-boggling. It just makes me nuts. I always want to take the computer and go sit outside. Of course, in Bergen, we have so much rain. That's not possible. So this is a very important thing for all of us to think about, and work through. Interior environments have really become our de facto natural environments, right? We are spending more than 90% of our lives inside, and most of it is really during the day and at the time that we sleep, and it has huge impact. But it has not always been that way, right? Just light has historically played a major role in formation of architecture. But its role has always been defined by its visual impact, right? It has been used for spatial navigation, for task performance, dramatic effects, emotional and evocational evocation of the embodied experience. But it has never really been used for these effects that we are talking about now, right? This is very new. The science is new, so everything else that is going with it is new. So I'm inviting all of you guys to be thinking in a very different way about our built environment, right? Light has been used for its warmth and color, has been used by architects and designers throughout the ages, essentially, for its ability to animate the space. But it's really the sort of its ability to make things visible that has been always the major role that it has played. We are now finding out that light has much greater on our health and well-being. Therefore, we need to really look at our environment differently. Let's look at some of the, so I'm going to talk about two sort of sources of light, of course, here. One is the natural light, the other one is the electric light. But as I said, light is only the intensity and spectral power and timing and duration that matters. So that's why when we talk about electric light, we can argue that light at night is really not the best thing. We can talk about that. Of course, today, sort of daylight makes it into the building environment mainly through windows and skylights, as you know. But historically, the architectural form itself was defined by access to daylight and its perceived healing and medicinal effects. Look at the plan of Paris, right around 1853 to 1870. Napoleon III declares that Paris needed light, then air, then clean water and good sanitation. And answering that, Eugene Haussmann's urban renewal of Paris, it takes, I forget how much, huge amount of money and 17 years to just really start and then complete it later. So this is a huge sort of endeavor really imposed on an existing city to make it healthier through light, introduction of light and air, if you will, in terms of form. And if you look at all these buildings, they would almost all of them have holes in between them, right? They have these open atriums, enclosed atriums to bring light all the way to the bottom of the interior of these places. Because without light in early 1800s, you had nothing. You couldn't do anything. So buildings would be useless. Daylight was hugely important all the way to the invention of what became electric light. Of course, electric light itself wasn't a problem right away. This was invented in 1880 by actually a British scientist, and later on sort of adopted and used for a became a commercial success by Edison. So Edison really didn't invent the light bulb. incandescent light bulb, but it was the Brits. So about 100 years ago, really is the time that we see bulbs get sort of wide, because then electric grid becomes more and more available. It's not just light bulb out and light bulb just brightens everything. It takes time before about actually 1930s when everything sort of starts changing. From early in the morning to late at night, you are exposed to very similar light environments now. If you think about it, we are getting about, if you are working, we are getting about 300 to 500 lux of light at the horizontal level, which would make it about 150 to 200 lux of light at our eye level on a vertical plane. And this is the same during the early hours of the day, and it is all the way at night. Where we were talking about circadian rhythms, we were talking about upwards of 100,000 lux of light during the early day, or noon, say, and then afternoon, and would get less and less, and it would be almost zero at night. If we had moonlight, we would have third of 1 lux, right? 0.31 lux, which is amazingly, I mean, the contrast is just huge, right? But then we have the electric light, and it is the same throughout the day. This has impact again. Okay, so now let's talk about how the shape and location and orientation and material of interior and exterior would impact light and the amount of light. In this slide, what you're seeing is that actually these are the same size, even though the middle one looks bigger, it's just held up. But the windows on these two, for example, are almost exactly the same, right? Windows on this orientation is a little, are smaller, and at the end of the room. So you can see the shape of the room and its orientation, even though sun would be coming, or sun daylight would be coming through that window, the shape would make a huge difference. Orientation would make a difference. We will talk about that, but you can guess that students sitting here would have a very different cognitive performance than students sitting there, right? And if you look at the average daylight factor, which is a way of measuring daylight, I don't know if you guys are familiar with daylight factor, but it is a factor of light that gets in, a factor of daylight available outside that gets in. So 2.5% in this shape gets inside on average. That means if we sort of control for all of these points in the grid, we would get 2.5% on average. And then in this one, you can see already you have a better daylight average. That means more light is penetrating more interior, and even more in this case. But all of that said, is 4.1 even enough? We will talk about that. So also, light has to come through an opening, and the location of that opening on the room makes a difference as well, right? So if you take the same room and put one opening the same size, same height, same width in different location, you would get a different daylight average. So location of your opening matters. Is not just, this orientation of the room and the size of the room and then the form of the room, but location of the windows matter. Then I want to go to the next, which would tell you also that the color of the interior matters, right? This is where architecture and, you know, making rooms for people really starts showing up. All the, you know, surfaces here are sort of lighter if you look at it. So you would get about at the end of the room, opposite end of the room against the window, you would get about 2% daylight factor. But here, things being the same, a little darker interior, you would get 1.7, and then even darker, you would get 1.4. Between 1.4 and 2, there is a huge difference, of course, but 2 itself is not sufficient for what we talked about. And all of these daylight factors that I'm showing you are really measures that were used for vision and task performance, okay? So let's go to the next. Now you're looking at the color of the glazing. Glazing itself filters light in a different ways. A plain sort of pane of glass would cut the intensity of light by about 20 to 30%. Just the plain, you know, you can see that this is clear glazing, right? So then if you add to that how it impacts the spectral power of the light, then you would understand that it has much more impact on its non-visual effects than just the intensity. But you can also see that blue is cutting another 45% and cutting 45%, and then bronze glazing allows only 30%. That means it's cut 70%. So here we are losing 30%, 55%, and then 70% of intensity. We're not talking about spectral power here, right? Okay. Then we have, of course, exterior systems to help us to mitigate heat gain and be more energy efficient and cut glare, which are absolutely necessary. But then we get to kind of funny solutions like this, that the advertiser is advertising maximum darkening. This is a German manufacturer, is just sort of proud of the fact that they can make it like night. And usually these things are automated and they come down as the light hits the wall, daylight, sunlight hits the wall. So imagine you have, you know, gone through the expenses and put all these beautiful windows out there, you know, looking at great views, and then sun hits the top and there goes the view and light and everything with it. So daylight is really subjected to a lot of manipulation and engineering that has to be sort of worked with. Let's go to the next. So it is really not until the second industrial revolution that the new system of production, availability of electric grid, and the light bulb gave birth to the modern lifestyle. What does that mean really? Is that meaning that now we could conquer the night together with these innovations, have divorced us. We can divorce us from dependent on daylight. With invention of light bulb, we invented really a new way of living, a new way of being, and new way of building. new way of making architecture. Then you have to sort of understand that today we live in a 24/7 societies with a great disdain for darkness and sleep, right? We want light all the way through the night. Lighting up the dark night allows us to feel safe, to work, to play, to socialize and do necessary or frivolous activities alike. We don't really bother thinking about it. Light is there, gives us this cue through the, circadian system that it is day, so you can be active, you can eat, and so on and so forth. As we spend most of our lives in interior light environments, the question arises, is the available light within these environments suitable for human health and well-being? This is the biggest question. So if you look at these two diagrams, you can see one sort of simulating your night and day in a natural sort of daylight and photo entrainment of that of your circadian system. And this one would be the way we all feeling now in the sort of a dim interior daylight sort of situation, and then sort of bright interior light environment at night. So I want you to pay attention to the amplitude of the wave, right, of this cycle. This is very high, and that is very low. Low amplitude sort of is a sign of circadian disruption, actually, meaning that we don't have a robust and a stable photo entrainment and a circadian system, meaning that we have disruption of the circadian system. This would affect our food intake, our sleep, our, as we were showing you, our mood and concentration and focus and. So it's very important for us to pay attention to these two sort of light environments and their effect on what we call photo entrainment of the circadian system, right? Okay. Now let's talk about daylighting and lighting regulations. Well, as you all know, historically, these daylighting and lighting mandates or standards have been developed for visual impact. So we can't really ask them too many questions. In about about 3 years ago, 2 years ago, actually, in 2022, Brown and his colleagues published a paper titled Consensus Recommendations for Indoor Light Exposure to Support Human Physiology, Sleep, and Wakefulness. These guidelines are based on the melanopic EDI lux definition, which was defined by CIE in a document called CIE S026, which I can sort of, in 2018. What that means really is that they are now defining lux in a way that would, takes into consideration its impact on health issues, on circadian rhythms, for example. Not just the lux that we had before, which was just a photopic lux, right? As I said, when you bring in other dimensions than intensity, so you have intensity, you have a spectral power, you have timing and duration, then you're talking about a different type of light. And that melanopic EDI means melanopic equivalent daylight illumination or illuminance, which deals with liking any light source to daylight and daylight effect on our health. So in that case, we understand, for example, an electric light bulb that we can buy, how would that compare to sun, right? Now we have on the market, what they call a full spectrum light. Are they really full spectrum or not? There is a sort of a melanopic DER, the ratio that shows us its efficacy, daylight efficacy ratio, would show us how that light bulb compares to sun. If the melanopic DER is 1, that means it would be like sun, right? But if it is less than that, that means there has to be an adjustment. For example, when you say 250 melanopic lux, it's one thing than saying, well, this light bulb puts about 500 lux out. Well, melanopic lux has these conditions that we were talking about. So you can read the, of course, the formula here, but that's what I was just telling you. So they recommended 250 melanopic lux at the vertical level, at the vertical sort of plane on the eye level throughout the day, from early morning to about, 5, 6 in the afternoon. And then after that, sort of reduction, at least 3 hours before sleep, would be around 10 lux of light. Again, melanopic light you're talking about, right? Which was sort of perceived and sort of processed by those neurons that we were talking about, right? And then at night, when you sleep, you need less than 1 lux of light, melanopic lux of light. Means absolutely almost nothing, right? So if you had, for example, red light at 10 lux, normal lux, that would be about 1 melanopic lux, red or orange light, right? Because if you have taken it's not comparable with the sun, except with the sun at sunset and sunrise, which is very sort of dim in terms of signaling the brain. Okay. So then we're going to be looking at some of these regulations and standards and sort of understanding them before we sort of look at them and see if they are sufficient or not. If you look here, you can see that, they are starting to change actually. In 2018, European standards have changed to go to 300 lux over 50% of it. So this is daylight we're talking about, right? So this is starting to address some issues, but when they say 300 lux, it does not, really specify melanopic lux, which would be daylight, but this is daylight, so 300 lux is 300 lux. But is it at vertical level or horizontal level, which is very different again. So the only standard really that has started sort of getting at it is the V2, which is talking about circadian health and alertness. But essentially, they are not really regulatory organization. They are sort of a voluntary certification organization. That means they can't really tell people what to do. If you do what they say, they will give you a certification. But looking further into their standards, I can see that their standards are also perhaps a little low as we speak. And their certifications have ABC, and the lower you come, the lesser of certification, I guess you get. But none of these other ones would address that issue. Most of the countries are looking at either size of the window or factors, like daylight factors, between 2 and 4%. And that is also ridiculously low, as I can show you in a second. So Bream and Reed and IBC really don't address any of the issues that within non-visual impacts of light. There has been some movement that way just recently after this 2022 paper that I was just talking about, right? They recommend their scientific recommendations, and that is changing somewhat. So let's talk about the last part, designing for health and performance. I really believe that the quantification of available interior light and optimization for timely and robust circadian photoentrainment, alertness, sustained vigilance, and better mood and physical and cognitive performance are extremely valuable to the future of architectural practice, but also public health. It's not just one thing, right? We need to understand, as designers, we need to understand architecture as preventative care. Or medicine itself. This is not a new idea. Architects before modern movement and through modern movement had these ideas from their public health and medical sort of time, medical thinkers at the time, that sunlight itself had a hugely important effect on human health. In addition, an environment that shows to improve health and well-being of the users provides both organizational and economic incentive and values for any user. In my studies, quantifiable, which I've called biometric architecture, quantifiable and reliable biomarkers, such as dim light melatonin onset, which I would talk about in a second, can help architects design evidence-based, human-centric spaces. Classrooms that enhance learning, homes and offices that promote mental and physiological health, productivity or rest in timely manner, hospitals that help the healing process, and more. As designers of the human environment, we can use biomarkers to understand the impact of a future facilities on people's health and propose cost-saving and inspiring solutions ahead of the time, right? Let's move on to my research is focused on the impact of available daylight and light in interior environment on the brain's regulation of circadian system by measuring a key biomarker. A biomarker is a tangible or measurable event, chemical or otherwise, in your body that can be measured as per impact of built environment on you. Most interior environments do not support the range of light exposure needed today for a stable and robust photo entrainment, as we talked about. And this is evidenced also through my research. So here I have two research questions, which you can read through as I'm talking about the 2 to 4% average daylight factor for new construction must be really challenged. This is the regulation right now. And we're talking about minimums. Of course, people can go beyond that, but we have set our study, which I will show you, so some of them in environments that have way above 4% daylight factor. So if you have read the research questions, we can go forward. We designed two interdisciplinary experiments involving architecture and neuroscience, of course, to answer these questions that we have asked, right? Through collecting salivary melatonin and daylight intake or light intake generally, sleep and wake activities, and so on and so forth. As you can see in the picture here, you'll see I went back, I don't know why. You can see activity graph, graphy watch, or active watch, we call them active graphy watch, and a light meter, which would collect melanopic lux plus timing and duration and intensity of it. So these two are important wearables for us that our participants wore throughout the project. Participants were students living in student housing, and they would have a daylight factor in their space, which we calculated to be from somewhere from 8% to about 6% daylight factor. But we had to actually do a light intervention to reduce this thing to 2%. So we had pre-intervention, we had more than 8, and then after intervention, we had about 2% to check what happens to their sleep, to their circadian rhythms, and so on and so forth. Okay, so what I'm showing you now is the hormonal circadian rhythms, which I have been concerned with, but mainly I really look at these two, and this one is the king for sort of light stimulus from the environment. So melatonin rhythms are important because as the night starts falling and the light goes down, as you can see, the secretion starts and goes up. These are hours here, right? And this is melatonin levels going up to peak right at the time that you are just right after the time that you are usually just very sleepy. Melatonin is really not making you feel sleepy, but it is the signal to other chemicals that help you sleep. But this is a good biomarker of the circadian rhythms. Another good biomarker of the circadian rhythms is the cortisol. Cortisol is what gives you, as you know, stress, but also makes you focus and makes you happy to be able to do things, kind of like energetic. And we're not going to talk about the rest of this stuff. We don't need to. So this is daily sort of melatonin cycle versus cortisol and body temperature. All of these are anticipatory sort of thing, and you can see their relationship with alertness or being vigilant, as we call it. So you see cortisol and alertness sort of follow each other perfectly, right? Cortisol is up, right after that, you're more alert. Cortisol goes down, you're less alert. So it just lags by a little bit, okay? All right, so our study showed that, okay, we took that 250 millinopic lux as our sort of stable marker, right? As our threshold. And we can see that pre-intervention, that means with all the light that was coming through the window, and then post-intervention, we are both of those are, even though we have better lighting pre-intervention than 2%, we are still below the levels that are given us. These were sort of collected on a wearable that people wore on their shoulder, almost, on lapel. So they would almost getting the amount of light they get at their eye level, right? So you can see that at the peak of, there's sort of, this is after they wake up, right? At the peak, they got 180 about millinopic lux. That's not enough as per recommendation. And it would fall after what? And this is before sleep onset. Even though we had asked them to turn the lights off, you can see they are getting more than recommended, which was, if you remember, it was 10 millinopic lux, right? They're getting more than recommended light all the way to the time they sleep. This is 3 hours after they wake up. This is 3 hours before they sleep, okay? So you can see that daylight factor of 2 here is not sufficient at all for their circadian rhythms. Then we have a collection. In this one, we have just one individual. I want to share with you one individual who is, you can see that the pre-intervention, she is doing okay. And her melatonin levels are up, at the fourth, we had taken 5 samples, right? At the fourth sample, they are up to almost its maximum, which means at maximum, she is sleeping. These are 1 hour apart. Okay. And then this is the cumulative one, aggregation of all of them. We had 13 participants, and you can see a good difference between pre and post intervention, with more than an hour of difference for the last one, for example, here. More than an hour of difference between this one, meaning that melatonin levels post-intervention got there late. Okay, so to explain this, late timing in circadian timing or circadian alignment, being late is negative, has adverse effects. Being early, on the other hand, is positive and has good effects because it, allows you to sleep well and to have sort of restrictive sleep and so on and so forth. And the later you go to bed, the less sleep you will have. And your sleep is not the same quality. So speaking of that, I have another question for you guys before we go to the next slide. Sleeping of sleep. How many of you use alarm clock? Just say yes, no. Alarm clock to wake up. How many? Do you have any answers yet?
It's a mix of answers. Yes and no, and used to, but don't now.
Okay, well, so how many of you use snooze alarm, snooze sort of button? Let's say, how many of you use the snooze button once?
Nobody's being honest about that one.
Nobody?
Nobody answered that one.
Oh my God.
Maybe
Okay,
nobody
well,
wants to tell you.
Nobody wants to tell me. Don't be shy.
wait,
It's okay.
I'm going back and forth between chat and Q&A.
Yeah.
Depends on what time I went to bed. No snooze ever. I set 5 alarms,
Okay, well,
no snooze.
yeah, well, that's good. 5 alarms is a snooze. It means you have problems. So anybody using a snooze alarm knows that they have a sleep problem. You have to check that. Let's talk about daylight and use of daylight as primary source. So when we talk about now this last part, we're talking about what is important, right? As a strategies for design. Daylight should be really used as the main source of lighting. And then paying attention to temporal and spatial distribution of light is very important. Ensure appropriate light at right time in the right location. Because, you know, architecture is not just one space. Usually it's many different locations and spaces. We have to be able to light them differently and appropriate time and appropriate intensity. Use electric light as supplement. What does that mean? That means the best electric light, really the best electric lighting is the one that is off when not needed. Try to understand this. When there is daylight and you can support the active light, you know, just use electric light as supplement. That has to come on once in a while. Dynamic lighting is very important. Lighting, electric lighting should mimic the light pattern and intensity and the spectrum when possible. And we should be able to have dark areas at night, okay? As I said, this is not a new idea, and it affects the way we should think about architecture, from the way we form and orient architecture to the way we use architecture. Architecture has been used as a sort of a healing tool or element for a long time in Western culture. Think about building orientation and layout, but also think about liminal spaces. It's the spaces that are sort of in between. Create places that are both indoors and outdoors, right? For access to unfiltered light and air, right? You know, sometimes old tech can help also to design environments that have a variety of spaces that people actually sort of, if you will, migrated throughout the day as well as throughout the seasons. And lastly, get to accommodate for chronotypes, age, and light sensitivity. Age makes a huge difference in the amount of light you receive through your eyes. A person at 80-some would have about a 10% of the light that we would get at the age of 10. Very different. And then teenagers, oh my God, teenagers have a very different chronotype than you know, their teachers. If the teacher was a little older, you would know that the teacher wants to wake up early and come to work early and have a better sort of cognitive performance during the earlier hours of the day. And the teenagers would want to come later, and their brain would not start working till about 12 o'clock in the afternoon, at noon. So you can't just ignore that and just bring the kids in at 7 in the morning anymore. That's it. So let's just open it for interaction.
Ali, that was extraordinary. So many questions.
Thank you.
And we've got a lot of people. Thank you so much. And we've got
That's
a lot
great
of
to
people
hear.
who want to talk. So let's start going through this. We'll start with a simple question, probably has a complicated answer. Which light source is the closest to sunlight?
Well, right now, there are two choices. One is tunable white lights that are full spectrum, and they're getting better and better, by the way. But the intensity is an issue still, right? Because just a light bulb going to 2,000, 3,000, 4,000 lux of light would be like really eyesore, right? So diffusion and all that is important. But the other part, RGBs are also very possible solutions. Tunable white lights are working only with what we call the color temperature. And then the RGBs work with mixing of different color lights. Both of them are good. Tunable white lights are more energy efficient, if you will. But they're,
Okay, let's,
again, they cannot produce sunlight. They get close.
let's go to something we haven't actually talked about, which is the design of personal homes. Can you help?
Oh yeah,
help
this
us?
is, yeah.
The question
Good.
is, according to natural light, I know some people say bedroom should be dark, while others say it should wake people up, and that's why it should be lighter. What do you recommend to think about in terms of prioritizing access to natural light?
Well, this is a great question, and I think it is very important to understand that when we talk circadian rhythms, we're talking about as sort of a cycle, right? So yes, at night, this bedroom needs to be as dark as possible. But if you, for example, had your shutters on, let's say, automatic system that could go up right before you wake up, that's the best, because natural light helps you to wake up a lot better, actually, and you would do better. But it's not a static system. It's not either light or either dark.
There's a couple of questions about products on the market. So one of them,
Yeah.
are artificial blue light devices on a desktop successful strategies to fight seasonal affective disorder, for example?
Okay, well, two things on that. There are some that actually are tested and work well. You have to really do your research before you buy any of these. Full spectrum would be perhaps better, but it needs higher intensity. Blue light, targeted blue light, let's say at 477 nanometer, which is this kind of light blue, kind of greenish, not greenish, but yeah, that is good, and you could use it at lower intensities to stimulate circadian rhythms. But you need that from early hours of the morning to later in the afternoon, to about 4 o'clock in the afternoon, let's say. After that, you need to turn it off. You need to sort of get less blue light after 6 a.m. 3 hours before sleep, no blue light at all.
All right, another question about a product on the market, and that is, what do you think of circadian LED lighting products, such as faux skylights, programmed to change throughout the day to match path of sunlight?
Well, here, I have to say that there has been like a lot of products out for the last 15 years. A lot of them are just marketing ploy because they ignore the science. There are some of them that work well. Following the path of sun is just fine. But again, you have to produce intensity and spectral power that would affect the non-visual system, right? Would affect the non-visual system. You can't just claim it. And a lot of these companies are just claiming it at this point. And then you have to sort of think how much money I'm paying for this thing, and is it working? If it is working, yes. So skylights are better I'm talking about skylights, are a lot better than just circadian sort of blah, blah.
Okay. All right. A question. Are you doing any research into the negative effects of lighting on human health, such as seizures, migraines, headaches, etc.?
No, I haven't done this, but there's good number of research on that. I have read some. And yes, flicker, for example, is associated with migraine um, and headaches, other headaches.
Question
Yeah.
about light challenges of an aging population. You had an image of older people. Can you speak to that again so we don't lose that point?
Yeah, as they remember that when I showed you the recommendations, they are talking about the age between 18 and 55, and they have a reason for this. The scientists have a reason for this. After the age of 40 some, your eyes start changing. Some people earlier, some people later, but about 55 and up, you start changing drastically. The eye itself turns a little bit of, inside the eye turns a little bit of color, it darkens a little bit. Therefore, it's impacting the spectral power of the light. But then also you are receiving less light because of that coloration and darkening. So a person at about 85, as I said, 80, 85, it has only about 10% of the light that they received at the time they were 10 years old. Okay, so imagine if I had to light a place for an older person, I have to think differently than when I'm lighting for, let's say, school kids, right? Very different. Not only the amount would affect their circadian rhythms, mood, and other issues that we have talked about, but also their vision is impaired as well, right? So falling is a very, very big issue because of lack of contrast and lack of enough light for vision for elderly. This is very important. Study after study shows that
we've had a couple of people
elderly,
say, let's start thinking about a second chapter of this presentation, and maybe we can get to more detail. I do want to ask, this is an interesting
Absolutely.
question that you haven't spoken to, and I'm curious also. One of our attendees is asking, in addition to intensity and timing of lighting, does the location of the light source relative to eyes impact their circadian rhythm / health, such as a desk lamp or window in front of you for 8 hours a day versus a ceiling light or skylight window above you versus ambient lighting around you? I mean, this is a really critical issue for designers.
This person is very smart and very to the point. Yes, it does make a huge difference. The direction of light, as we talked about the recommendations, we were talking about light at a vertical plane at the eye level, right? So the more direct it comes to your eye, the better. So ceiling lights are not the best for circadian lighting, right? Desk lamps are better.
I'm going to ask a little supplemental question here, because we've done a lot of testing with people with brain and sensory issues, testing the role of a task light, and have found them quite powerful in terms of focus and concentration.
That's very true. That's very true. Actually, lighting I have had a few colleagues that have done this at the school levels too, to bring noise down instead of going through acrobatic acoustic sort of solutions. They have used light to bring noise down by virtue of having people focus around a light sort of envelope, if you will. So light has that quality. If you make you focus, less noisy and more attentive. That's it.
Somebody's asking a very specific question. I want to give this an opportunity for you to answer. Was the device you used to quantify melanopic lux commercially available?
Yes, it is. I can put it up. It's called the Nano Lambda, the company. And but the data that comes out of it is really convoluted. There are a few other ones out there in the market as well. So yes, there are. And I am actually working with a bunch of people in setting standards for these. Yeah, go ahead.
Actually, if we could just ask you to reflect for everyone about this issue of setting standards and what's next. I mean, I think what you've done is really open our heads to a sense of priority that really looks at, we've paid a lot of attention to light in relation to energy use, and we really need to balance that with light in relation to human need. Is that fair to say?
That is very, very, very fair to say. I add to that that this is a paradigm shift that you're working on. Generally speaking, when we talk about architecture and built environment, we are right now, at least, talking constantly about all sorts of technological issues and all sorts of energy use and carbon footprint and sustainability. And all of these issues are very important. But more important than that is we are designing human environment. We are not, I mean, if we just, for example, I was just telling this to an engineer friend, if we were just thinking about energy efficiency, then we would just eliminate all the windows and make a box and then put people in them, and that would be fine, right? Well, no, because that's not a human environment, that's all. So we are approaching architecture from a human need sort of angle.
Ali, this has been extraordinary. You must be exhausted. You've been so generous in sharing so much information. You've gone almost an hour and 45 minutes. So any
That's
last
amazing.
points you'd like to make? Because we certainly hope to welcome you again. And you and I know, are hoping for opportunities to do some research if we can find somebody who's still got some money. But
Yes.
we really believe, IHCD, I want to state, has an absolute conviction that we are ready for neuroscience to give us the data we need to inform design.
Yeah.
And that there is an urgent need to really get people aware of these extraordinary insights as to what really impacts on human health and experience.
Yeah, and your question also brings up this idea that this is a very sort of vast and complex field, right? Both architecture and neuroscience. And then when you combine these, then it's just even more complex. So I would recommend that people get familiar with this stuff and get help when they need it. But also don't oversimplify. For example, the recommendations I put out, the scientific recommendations I put out, sometimes are looked at very simply and then used as a sort of formulaic approach. Don't do that. You need to sort of be a designer and look at this sort of environment of health and healing as a designer, as a creative person. You are creating things that are going to have impact on people.
Okay, thank you. Go and get yourself a glass of water. Thank you, Ali.
I will do that.
I want to let everybody know that this whole presentation will be available once we have edited the captions. That should be in about 2 weeks. So warmest thanks to you, my friend. Now you can go have your dinner. It's evening.
Yeah,
I
have to, yeah, it is. So talk to you guys later, and thank you for having me.
Absolutely. Thank you. Be
Bye.
well.
Bye.